of wonder and discovery.
Roger, Eagle, contact.
6 trips to the lunar surface revealed much about our closest celestial neighbor and changed forever the way we view our own planet. Today, NASA is looking towards returning to the moon. A permanent lunar base would complement space station Freedom and provide a springboard for manned missions to Mars. And if researchers at NASA's Center for the Commercial Development of Space in Wisconsin are successful, the first lunar settlers will also be miners. Actually, this large automated vehicle would do most of the work, processing the moon's rocks and soil to remove a potentially valuable product, helium-3. Just 25 metric tons of this rare isotope, roughly the capacity of the shuttle cargo bay, could provide enough energy to generate all the electricity used in this country in an entire year. Helium-3 is produced by fusion reactions in the sun and carried through space by the solar wind. Earth's atmosphere shields us from the solar wind, but it has been depositing helium-3 on the moon for more than 1 billion years. Former Senator Jack Schmitt was part of the Apollo 17 mission, which marked our last, or as he likes to say, our most recent journey to the lunar surface.
We can't always use fossil fuels for the production of electricity. There are many environmental reasons why you don't want to do that. One of the most popular now, of course, is the addition of CO2 to the atmosphere. We don't need to panic, but we ought to be making those kinds of research and development plans that we have an alternative to coal and other fossil fuels in the not-too-distant future.
Studies indicate that the amount of radioactivity in a device like this generating energy from helium-3 will be 1/1,000,000th less than in nuclear systems used today, and no greenhouse gases, acid rain, or solid wastes will result. The proposed mining system will be equally kind to the lunar environment. Once helium-3 has been boiled off, the untainted rocks and soil are returned to the surface, leaving it essentially unblemished. The process should also produce a number of byproducts, including water, which will be of great value to a lunar colony. And according to Jerry Kolsinski, a professor at the University of Wisconsin and member of the NASA Commercial Development Team, current oil prices make helium-3 an even more attractive alternative.
At today's prices, helium-3 would be worth $4 billion a ton, which would make a shuttle load worth about $100 billion. And that's enough, I think, for any businessman to figure out a way to make a profit.
Helium-3 mining, using the moon's resources to meet future energy requirements on Earth. Earth's atmosphere. It's the air we breathe, the force that regulates our temperature, weather, and importantly, what cleanses pollutants from the environment. We've begun to realize that our atmosphere has no geographical boundaries when it comes to pollution. Airborne industrial waste in one area can litter forests thousands of miles away with acid rain. Due to our everyday activities, a host of gases such as carbon dioxide and methane are being released into the atmosphere at alarming rates. These greenhouse gases are known to trap heat near the surface of the Earth that otherwise would radiate into space, potentially causing serious global warming. This problem has been studied by scientists for many years, but never with the detail an airborne observatory can make flying at all levels of the atmosphere. To do this, U.S. and Canadian scientists teamed up to study greenhouse gases in the remote northern latitudes of Canada. The program, called ABLE for Atmospheric Boundary Layer Experiment, is the third in a series of NASA-sponsored research expeditions. Initiated in the early 80s, ABLE will eventually study major ecosystems around the globe to better understand the dynamics of our atmosphere. With the help of McGill University, a ground-based site was chosen in northern Quebec that featured a forest and wetlands environment. Scientists from Harvard and the State University of New York built a 100-foot tower at the forest site to sample atmospheric chemistry and collect meteorological data. Meanwhile, NASA Biospherics researcher Gary Whiting and assistant Joel Canez spent countless hours at the nearby wetlands, measuring gases given off by these grass-like sedges. Detailed studies of the marsh plants were also made by a group from the University of Delaware to characterize their growth patterns and how they transport methane gas into the atmosphere. Because of their hollow stems, these plants are very efficient transporters of methane, piping the gas directly into the sky. Many other measurements, such as balloon sondes, track local winds, temperatures, and humidity. An Electra aircraft from NASA's Wallops Flight Facility, Virginia, flew repeated missions over the sites. 7 experiments took air samples and measured various chemical concentrations. Dr. Ed Browell of NASA's Langley Research Center used an instrument that shoots a laser beam above and below the aircraft to plot a cross-sectional view of the atmosphere. The reddish-orange colors represent regions containing higher concentrations of ozone, another greenhouse gas. Studying atmospheric events from the sky and the ground, giving scientists an unprecedented glimpse of the health of our global environment.
Columbia, Houston, we have a tally-ho on LDEF.
Called the Long Duration Exposure Facility, this 11-ton satellite had been in space for almost 6 years when a shuttle crew retrieved it and brought it safely back to Earth.
3, touchdown, welcome home.
After delivery to the Kennedy Space Center and several months of close inspection, LDEF became an empty shell. Its 57 external experiments were shipped to scientists around the globe, including a group at NASA's Langley Research Center in Virginia. The effects of long-term exposure to space can be seen in this materials and coatings experiment. According to Wayne Slemp, a senior engineer at Langley, the various colorations and stripings evident on the surfaces here were not present when LDEF was put into orbit. In fact, the top of this panel looked exactly like its unexposed underside prior to the journey. The goal is to determine the significance of these changes so that future spacecraft and structures can be built with the best possible materials. Don Humes, a Langley aerospace technologist, had 22 aluminum panels positioned around LDEF. Their mission was simple: be struck by micrometeoroids and other man-made debris. Determining how many particles are out there, where they are, and what they're made of is critical in designing future protection for astronauts and spacecraft. Research scientist Gail Harvey is discovering that a thermal control paint used almost universally on spacecraft can contaminate optical materials. This unexpected brown staining will almost certainly result in an across-the-board change in surface coatings for space applications. Learning more about cosmic rays is the goal of an LDEF experiment at the Naval Research Lab in Washington, D.C. According to physicist Jim Adams, cosmic rays are fast-moving particles that can penetrate human skin and disrupt onboard computers, another factor to be considered in developing future space hardware.
Technologically, what will come out of LDEF is a set of handbooks which will be the Bible for how spacecraft are built for the next 20 or 30 years. I think it'll be a very long time before there's an opportunity to fly such a large spacecraft for such a long time and learn so much about the effects of the space environment.
More than 12 million tomato seeds carried on LDEF have been distributed to students of all ages around the country. The majority of the plants eventually produced normal fruit, and a second generation is planned. In addition to providing valuable information about the effects of space on living matter, the Seeds Project is designed to excite young people about science. the Long Duration Exposure Facility. 6 years of unparalleled information extending our future capabilities in space. Kitty Hawk, 1903. The success of the Wright brothers put America at the leading edge of aviation. While the Europeans pulled ahead during World War I, that edge was recaptured and maintained by the NACA, the National Advisory Committee for Aeronautics. For 75 years, the NACA NASA team has continued to fulfill this mission, to supervise and direct the scientific study of problems and solutions of flight, both inside and outside the cockpit. Dramatic advancements have been made in reducing drag and increasing speed. For instance, in 1947, while piloting the X-1, Chuck Yeager broke the sound barrier for the first time. And the X-5 proved a variable sweep wing could fly. The X-15, tested from 1958 to 1968, was the first aircraft to fly 67 miles high along the fringes of space. Reaching 4,500 miles per hour, it came back to an aerodynamically controlled landing. Inside the cockpit, control panels, once a myriad of dials, are being consolidated into easy-to-read monitors, enabling pilots to fly better and safer. Also helping the pilot are flight simulations. For a while, the only way to get the feel of an aircraft was to fly it. Flight simulations show how an aircraft will perform without leaving the ground. Together with wind tunnel testing and computational fluid dynamics, engineers and pilots have the best information possible before actual flight tests. Aeronautical improvements like these have led NASA to a blending of air and space. Case in point, the lifting body concept. Half spacecraft, half aircraft. A lifting body achieves aerodynamic lift from the shape of its body alone. Lifting bodies were precursors to NASA's successful Space Shuttle.
And we have touchdown, nose gear coming down.
Flight experience from many programs has led to the planned X-30, also known as the National Aerospace Plane. This research vehicle will be a true air-to-space machine, taking off like an air-breathing aircraft and accelerating to 17,500 miles per hour into low Earth orbit. NASA's world-class aeronautics program. 75 years of continued achievement in air and space.